We make data-driven decisions using analytics. How Bayesian statistics can impact supply chain risk management. Bayesian statistics can have a significant impact on supply chain risk management by providing a framework for quantifying uncertainty and making decisions based on probabilities. In supply chain risk management, there are many sources of uncertainty, including demand variability, supplier performance, transportation disruptions, and natural disasters, among others. Bayesian statistics can help supply chain managers make better decisions by incorporating these uncertainties into their decision-making process. For example, Bayesian statistics can be used to update the probability of a risk event occurring based on new information. This is particularly useful in supply chain risk management, where new information such as supplier performance data, weather reports, and market trends can impact the probability of a risk event occurring. Bayesian statistics can also be used to estimate the impact of a risk event on the supply chain. By using probability distributions to model the impact of different risk events, supply chain managers can assess the potential consequences of a risk event and make decisions accordingly. This can help supply chain managers allocate resources more effectively and reduce the impact of a risk event on the supply chain. Additionally, Bayesian statistics can be used to optimize supply chain decision-making. By using Bayesian networks to model the relationships between different variables in the supply chain managers can identify the most critical variables that impact supply chain performance and allocate resources accordingly. This can help improve supply chain efficiency and reduce the impact of risk events. Overall, Bayesian statistics can provide a powerful framework for supply chain risk management by enabling more informed decision-making, better risk assessments, and more efficient resource allocation. How Bayesian statistics is computed in supply chain risk mitigation. Bayesian statistics is a statistical method that provides a framework for updating probabilities based on new information. In supply chain risk management, Bayesian statistics can be used to quantify uncertainties, estimate the impact of risk events, and optimize decision-making. To compute Bayesian statistics in supply chain risk mitigation, the following steps can be taken. Define the problem and identify the relevant variables. The first step is to define the problem and identify the variables that are relevant to the problem. For example, if the problem is to estimate the probability of a supplier delivery delay, the relevant variables could be the supplier's historical delivery performance, transportation network performance, and weather conditions. Specify prior probabilities. Bayesian statistics start with an initial probability distribution, called a prior probability. Prior probabilities are based on past experience or subjective knowledge of the problem. For example, the prior probability of a supplier delivery delay could be based on historical data on delivery performance. Collect and analyze data. The next step is to collect data and analyze it to update the prior probabilities. For example, if the problem is to estimate the probability of a supplier delivery delay, data on the supplier's current delivery performance and transportation network performance could be collected and analyzed. Update the probability distributions. Using Bayesian inference, the prior probability distributions are updated based on the new information. The updated probability distributions are called posterior probability distributions. The posterior probability distributions provide an estimate of the probability of the event occurring based on the new information. Use the posterior probabilities to make decisions. The posterior probabilities can be used to make decisions, such as whether to order additional inventory or find an alternate supplier. The decision can be optimized by considering the potential impact of the risk event and the cost of the decision. In summary, Bayesian statistics can be computed in supply chain risk mitigation by defining the problem, specifying prior probabilities, collecting and analyzing data, updating the probability distributions, and using the posterior probabilities to make decisions. What is the formula of Bayes' law? Bayes' law, also known as Bayes' theorem or Bayes' rule, is a mathematical formula that provides a way to update probabilities based on new evidence. It is commonly used in Bayesian statistics and probability theory. The formula for Bayes' law is PA, B, equals PB, A, PA, PB. Where PA, B, is the probability of A given B, also known as the posterior probability. PB, A, is the probability of B given A, also known as the likelihood. PA is the prior probability of A. PB is the prior probability of B, also known as the evidence. In words, the formula states that the posterior probability of A given B is equal to the likelihood of B given A, times the prior probability of A, divided by the prior probability of B. In other words, it provides a way to update our belief in A based on new evidence B. Bayes' law can be used in many different applications, including medical diagnosis, weather forecasting, and risk analysis in supply chain management, among others. To learn demand forecasting, please email us to krishnaidu@mapmill.com or call or WhatsApp us at +91 to 8,977,924,637. For consulting and training, email us at krishnaidu@mapmill.com or WhatsApp us at +91 to 8,977,924,637.